Let's start.
Right, so it's 4x to the third power. Or it's 2 to the third power.
Say it again.
4x
To the fourth power.
2 to the third power. Like 2 over 3.
Here.
Yeah.
So 4x power 2 over 3. Okay.
Minus 35x to the 1/3 power. Minus 9.
Very good.
0. And
Per-
then to use substitution.
Of course. Of course. I wouldn't know how to do it in any other way. Perfect. So obviously, I am indicated to use substitution. But it's obviously that this, if I denote this by t, this will be t squared. Because if you take x to 1/3 and you square it, you copy the base, multiply the exponents, and get 2/3, which is this, 2/3. So that's why this is indeed an equation quadratic in form. It's not a polynomial equation. I have no idea what to expect here. So then the equation becomes 4t squared minus 35t minus 9 equals 0. It's not, this particular situation is not difficult to factor. However, remember you have to go through all the steps, and obviously the leading coefficient is not 1. So then I have 4 times negative 9 will be negative 36. The product is negative 36, and the sum is negative 35. So that's not a big issue because it's negative 36 and positive 1. But you don't have to do this. You can just use the quadratic formula, whatever it is, whatever you like to do. So this is 4t squared. Since I wrote this, I'm going to continue. Plus t minus 9 equals 0 from here. Remember, this is important, very important to remember. From the first two, I will factor out 4t, and I get t minus 9. And if I don't get a t minus 9 from the other two, I'm in trouble. But I do, with plus 1. So then t minus 9 becomes the common factor, and 4t plus 1. So from here, I know t equals 9 and t equals negative 1/4. But this is not enough. I'm happy I got something, but I have to go back and create two new equations in which t gets replaced by x to 1/3, or the cube root of x. So this equation is the cube root of x equals 9, and this equation is the cube root of x equals negative 1/4. Was this in my math lab? Quite involving, because the numbers are ugly and big and yeah, quite involving. We haven't finished yet. Okay, we only know now that the square of the cube root of x is 9, and we have to cube both sides, and we know that the cube root of x for the other solution equals negative 1/4, and we have to cube that too. Let me see if I turned off my. Yes, I did. Okay, so x equals 729, yes, 81 times 9. And here from here, x equals negative 1 over 64. Of course, I have to go back and check because I cubed, but remember, the odd powers are friendly. Any questions on this? It was quite long and cumbersome. I'm not saying that to deter you from asking questions. I'm just saying this is the case with this problem. A lot of work. Anything else? Anything else? Yes, please. Yes, I'm ready. 9x to the fourth minus 25. Good. So I think we should just start it and then you can finish it later, because you have to write this. You know it's polynomial degree 4, and you have to have 4 solutions, right? So I'm going to say let y be x squared, because this is y squared. So then 9y squared minus 34y plus 25 equals 0. And from here, determine the y's using anything you want. Quadratic formula is fine. And then you will create 2 new equations. X squared equals this number, and x squared equals that number. I'm saying that only because it's very similar to the previous one. But if you say that this is not good enough, then I'll finish it up. Is this good enough or not? No, it's not. Okay, very good. So let's find the solutions. Can you give me y? 34 plus or minus the square root of 34 squared minus 4ac. 4 times 25 is 100, so minus 900 divided by 18. So let's get our calculators. So I have 34 plus the square root of 34 squared minus 900. And I divide everything by 18. Okay, one solution is 1. And the other solution, 25 over 9. There are no questions here, right, for just using the quadratic formula. Is that okay? Okay, so then from here I have two options. X squared equals 1, and from here x squared equals 25 over 9. After getting the two solutions. I use the calculator for that. So then from here I will take square roots, and I get x equals plus or minus 1. The same thing here, and I get x equals plus or minus 5/3. Anything else? Any questions? Yes, please.
This was on the MyMathLab.
Yes. It's a different question or a question on this one?
Different question.
Oh, yeah, of course. Anyone has any questions on this one that we just finished? Okay, I'm ready.
So it's like the absolute value, 2x plus 2 over 5. And then is less than 2.
Like this?
Yes.
Perfect. So this is completely cleaned up. It's an absolute value inequality. It's the nicest of the two, in which I translate like this. It has to be in between -2 and 2. So far, so good? Okay, I need to get to x. In order to get to x, I have to eliminate 5 first, multiplying everything by 5. So -10 less than 2x plus 2 less than 10. In order to get to x, I have to eliminate this free term, the 2. So I will subtract 2 from all three sides. -12 less than 2x less than 8. Final step, I need to get rid of this, so I will divide both sides, by all three sides, by 2. Is this okay so far? Any questions before we write the final answer? Any questions? So -6 is on the left, x is in the middle, and 4 on the right-hand side. And in interval notation, -6, 4. And since this looks like an ordered pair, I highly recommend write x is a real number in the interval. So everyone is in the clear and understands that this is not an ordered pair, x comma y, but the answer to something else. Yes, please.
That's also the form you want on the test map?
Yes, that's it. The question will say solve the inequality or inequalities presenting the solution in the form of an interval or in interval notation. Yes. Very good. Anything else on this or anything else? Other questions for me? Anything? Okay, so let me just show you where we are, and I'm really hoping that you're keeping up with the pace, because this is just, we meet only twice a week for an hour and 20 minutes. So we completed this, and we have 5 more sections till we schedule the test. Before the test, we will have a review. So the entire session will be a review. I will bring you an old test, and we'll go over whatever we should expect on the test. So today, I'm trying to accomplish 2.1 and 2.2. Hopefully, these two will be done on Monday. Hopefully this on Wednesday, and review. If we can do all, if not, I can move 2.5 to, there is a part of 2.5 that I possibly can leave off, or just 2.5. We'll see. But we cannot, I have to have the test, if not on this day, the following session. So we'll see. If we don't get the chance to finish up 2.5, 2.5 can be connected to the next test. It's fine. Okay, so the next steps with 2.1 and 2.2, it's a lot about functions. So this is chapter 2. It's all about functions. I know you remember a lot about functions, but I will still have to make sure that we are on the same page. So first, 2.1. Well, they're together, I would say. 2.1 and 2.2, it's all about functions. Different pieces of information, domain, range, but I want to take it slowly. Okay, so let's first look at the definition. What is a function? And I'm going to give you 3 situations. Situation 1, situation 2, and situation 3. These are sets of numbers, of course. Sets of numbers. This is the first set, and this is the second set. And I'm going to create a connection between them. And here's the way I create the connection. This is one number, this is another, and so on and so forth. In the second situation, I'm going to do this. And in the third, I'm going to do this. Of course, one number, different numbers. So all these situations have a first set and a second set. Now, the first set, of course, will always have values of x. X values. The second set will always have y values. For all of them. Now, anyone remembers what a function is all about? What does the function, what are the properties of a function?
One x value cannot have more than 2 y values.
More than one. Correct. So, in other words, in short, for each x value, only one y value. For each x value, only one y value. For each x value, only one y value. Is this a function?
Yes, ma'am.
Yes, awesome. So is this a function? Now, I need this concept for later, not for this first test, but I want us to be aware of it. Let's suppose now I reverse the order. So now I'm here, and I want to see if going backwards, I can create a function. So if I'm here, and this is x, it goes to this point, to this y value. If I'm here, this is x, it goes to this y value. If I'm here, then it goes back to this y value. So going backwards, can I create a function? Yes. So such a situation, it's a special property of the function. It's also called one-to-one. One-to-one. Why is this so important? It's not for this chapter and not for this test, but it will be for the next test. Super important, because only one-to-one functions have a very important property. So what does one-to-one mean? Also to each y, only one x. Not only each x to only one y, but each y only to one x, going backwards. And you'll see why later. Yes, a question?
Oh, no.
No. Okay, so now what about the second situation? What will you say? Is the second situation a function? No. So this is called relation. Why? Because I found it's sufficient to find one value of x that goes to two different y values. That's sufficient to say this is a relation. What about the third situation? Is this a function? Yes, because each x corresponds to one y. Each x corresponds to one y. Each x corresponds to one y. So this is indeed a function. But now my question is this function one-to-one? No, because going backwards now I cannot create a function. But not one-to-one. The first set for all three, regardless whether it's a function or not, all three is called domain for all of them. What is the second set called where the y values come from? Perfect. Excellent. So if we are given the relationship, the connection between values, we can identify whether it's a function or not. Perfect. But what if we're not given the relationship, but we are given graphs? We could be given graphs, and we would be asked, well, is this the graph of a function? So I'm going to show a few examples, a few graphs. And let's look at these three and identify whether they are functions or not.
So you want me to let's answer now?
Yes, what do you think? If you remember, it's okay if you don't. So for this x value, I read a y value. For this x value, it crosses the graph, and I read the y value.
So one-to-one.
No, a one-to-one will be when I use a horizontal line test. This is the vertical line test.
I'm sorry, okay.
That's okay. So the vertical line test says, for this x, I only get one y. For this x, I get only one y. Is this a function? Yes, this is a function. But what about here? For this x value, I read this y value and I read this y value. Is this a function? No. So this is a relation. What about this one? Bless you. What about this one? Indeed, it is a function, but it's not one-to-one. By the horizontal line test, it will not be one-to-one, but we will talk about it when we get to that. Yes, any questions? Any questions? Okay. Good. I'm hoping that you're in the back over there, you're paying attention. I'm really hoping that you'll put your cell phone away. It's a calculator? Okay. Okay. Whatever it is that you're doing, I hope it's not as important as this. The next situation that I would like to discuss is, for example, we're given an equation. Let's say x squared plus y equals 10. We're asked the same question. Is this, or does this represent an equation? Is this the equation of a function?
Yes.
What will I have to do? So what I have to do for sure is solve for y. So please remember, we solve for y. In these situations in which we are given an equation, we are asked, does this represent the equation of a function, or is it a function or not? We have to solve for y. Not a problem. We solve for y and we get negative x squared plus 10. And now if we want to say, okay, when x is 0, how much is y?
Square root.
Very good. When x is 1, how much is y?
11.
Careful. 1 squared with minus in front. This is not like this. It's like this, which means 1 squared. We are done with the power, and then we multiply by negative 1.
9.
Perfect. And I can go on forever. How many y values do I get for each x value? Indeed. So what do we conclude then about this equation? It is a function. No, we are not talking about one-to-one here. I just emphasized it or gave you an idea, but no, we're not discussing one-to-one just yet. We are only asked, is this equation the equation of a function? Yes, because for each x value, we only got one y value. For each x value, we only got one y value. And we can continue forever. We will always get just one y value. Would you agree with that?
Yes.
So I'll say function. Now let's say we have 4x equals y squared. Same question. Is this equation the equation of a function? I cannot just say yes or no, but you're correct. I have to agree you're correct. But I have to show. What do I have to do is this. Yes, please.
Why can't you take the properties of the equation into effect? Where you know it's going to be two, there's going to be two y values.
Absolutely agree, but I have to show. I have to show. First of all, I have to show for those who did not see that. Then I have to show what to do in case this problem pops up on a test. We have to show the work. Just an answer of yes or no will not give you full credit. So, solving for y means y squared equals 4x. How do we solve this equation? First of all, what is it? What type of equation is it? Well, it has two variables in it, right? So, but I know that once I'm solving for y, it's quadratic in y. Good. So how many solutions do I have to get? Good. How do I solve it? Awesome. Take the square root. Good. So then y equals?
Square root of 4x.
Nope. Yes, but not sufficient. To the square.
Plus or minus.
Ah. That's why I said from the beginning quadratic, which means two solutions, and so on and so forth, correct? Please do not forget, every time we take the square root, we have to write plus or minus, please. So then, we don't have to go and present too many ordered pairs, but here's one. When x equals 4, how many solutions do I get? Square root of 4 is 2 times 2. So then we have two options. Y equals? Very good. And y equals? So what do we conclude about 4x plus equals y squared? Is it a function or not? That was the question. We showed if you want the bubbles, you can show this. 4 and negative 4. Therefore, this is a relation. Is that clear? Questions for me, please? Okay, so in this section, I would like to look at a couple of graphs. And I'm going to ask you, and we're going to work together on several questions here. Okay, this is on page 230 and page 231. So first I would like to read from a graph, and then after we read from a graph a lot of pieces of information, then I like to look at the function notation, etc., etc., etc. So I like to look at this problem. Okay, so first of all, first question, I'm going to write down all the answers and then I'll post them. I'll put them for you. Okay. So what would you say about this? Is this a function? By the vertical line test, this is the function. Okay, so that's problem 82 on page 231. 82 on 231. Question number 1, function by the vertical line test. Question number 2. Now let's take a look. What is the domain of this function? So remember, the domain is measured on the x-axis, correct? From the leftmost point, which is about -6, to the rightmost point, which is, if you want, x0, right? However, notice that this is a full point. And notice that that one is a open or empty point, correct? So what would you say about the domain? And remember, we are reading it on the x-axis. From? Very good. Domain from parenthesis -6 till
0
with a bracket. Excellent. Thank you. What do you think about the range? Remember, the range is measured on the y-axis from the lowest point to the highest point on the y-axis. The function only exists between this point and that point. So what would you say? What is the range of this function? Yes? Yes. Comma 4 with a parenthesis. Is this okay? Good. So now the next concept that I'd like to discuss is Sx. Any questions?
Shoot, they look good.
Everything okay?
I do.
Okay. Yes, please. Yes, please.
Why was, if it's on the y-axis, would it be the second of the word pair?
We're only talking about the y values. The range is a question only about the y values. There is no discussion about the x value. When we talk about the domain, there is no discussion about the y values. So the domain is from -6 for x till 0 for x. The range is from -3 for y to +4 for y. No combination.
Wouldn't it be open?
Yes,
Oh, I'm sorry.
yes. It is open.
Oh, I'm sorry, I need to, like, infinity? No, because, oh no, never mind. It is open.
Yes, so something like this will go to infinity, the arrow. But in our situation in number 82, it clearly cannot go beyond. Unless it continues, but it does not. Very good question. Perfect. So now, here's a question for you. As x goes from -6 to 0, what does the function value do? Decreases. So this is a function that is a decreasing function, decreasing trend. So question number 4, f decreasing on the entire domain. Very good. Can anyone tell us whether this function crosses the x-axis? Yes. So there is a 0 of the function or an x-intercept. And can anyone give us the ordered pair? So -4, 0. Very good. Number 5, -4, 0 is the x-intercept. Perfect. Does this function have a y-intercept? Can anyone give us the ordered pair for the y-intercept? Very good. Y-intercept. Perfect. Now I'm going to ask you the following question. Find f of -2. So that's number 7, f of -2. What is given in the question of f of -2? Careful. F of -2.
The x value.
That's okay. The x value is given. Remember, when we are given just the x is a vertical line. X equals -2, right? So imagine that you draw, or you actually draw, a vertical line at x equals -2. It will hit the graph here, and then you will have to read the y value. I know it's difficult, but we can come up with an approximation. So what would you say this is?
-2.25.
Yes, we want to be very exact. Okay, that's fine. So -2, -2.25. Perfect. Final question here. Find x for f of x being 2. So now I am told f of x is 2. What does that mean? Which coordinate is given to us, or which of the two, x or y? Y. But y equals 2 is a horizontal line. Y equals 2 is a horizontal line. It hits the graph right here, and I would be reading the x value. It's not exactly -5, since it's slightly to the left of -5. So the answer would be f of x equals 2 implies x equals -5.2, and the ordered pair is 2, -5.2. So we identify the domain and range of this function after we said by the vertical line test, this is a function. Then we said the function is decreasing. That's sufficient. This is how I would recommend you present it. It's decreasing all the time for any x. When we talk about the trend, we're talking about the x values. We're not saying that the trend is decreasing from 5 to 2. We're saying it's decreasing between x and x. So it was decreasing entirely all the time between -6 for x and 0 for x, not from which y value to which y value. Okay, then we identify the x-intercept and the y-intercept, and then we were asked to find f of -2. So we drew a vertical line at -2 and we got this number. And then we were asked to find x such that f of x is 2, and we got -5.2, drawing or imagining that we drew a horizontal line at 2. Any questions for me so far? Any questions? Any questions? Moving on? Ready? Okay, thank you. So now, I would like to talk about function notation. And you could say, why is it so important? I mean, we've seen this before. Why are you talking about it? Well, because I would like us to establish something very important from the very beginning when we talk about functions. So, can anyone give me any function? Polynomial, quadratic, in other words, if you want quadratic or linear or rational or radical, give me any function you want. The notation we know, it's f of x or t of p or v of x, any notation, right? This is a notation, the name. I didn't mean to write that. I don't know what I'm writing there. I'm going to say name. I'm going to erase that. That's the name of the function. And this is the independent variable. It's also the dependent, that one. So the independent variable or the argument. Argument of the function or the independent variable. This is also y or the dependent variable.
I have a question.
Yes,
Because
please.
I've never heard. Did they usually use that term?
Argument?
Mostly? Yeah.
Yes.
Let's
Yeah.
say I've never heard of it before.
Yeah, it's the argument of the function, yes. Okay, perfect. So the function here is denoted by t, and the argument or the variable inside the independent variable is p. This function is called v, and the independent variable is x, and v is the dependent variable. Now please give me any function you can think of. Rational, quadratic, anything you can think of. You want 2x plus 1. Perfect. What type of function is that? 2x plus 1?
Yeah.
Perfect. Awesome. F of x, 2x plus 1, indeed linear. So when you give me this function, I would like you to understand and hopefully see what I see. This is what I see. I see what the function is telling me. The function doesn't say f of x equals 2x plus 1. The function says f of whatever you want equals 2 times whatever you want, but it's the same with the inside of f, plus 1. In other words, if you say to me, okay, evaluate this for 15, okay. Then you can say, evaluate this for x plus h, okay.
Just plug in.
Exactly. Evaluate it for 0, okay. And I can go on forever. So I don't see x. I see f of something equals 2 times that something plus 1. Very important to understand that concept. And now I would like to look at a function. Let's say 34. You'll tell me which type of function this is on page 230. F of x equals the square root 25 minus x and minus 6. And they're asking us to evaluate it at 16, to evaluate it at -24, and evaluate it at 25 minus 2p. Keep in mind what I see, and I hope you see the same thing. I see f of blah equals the square root of 25 minus blah minus 6. This is what I see. And if you understand that, you will never make a mistake. I know it sounds silly, and it is silly, but I just want to make a point. So f of 16, obviously, can anyone dictate? Minus 16 minus 6. This is the first step. And then, yes, so the square root of 9, which is 3. And then you will say 3 minus 6, which is negative 3. Can anyone give us the ordered pair that we just determined? We determined it. Indeed. Thank you. So 16 comma negative 3. Y is here. X is here. Perfect. Now let's find f of negative 24. What would you say? So you will write it as the square root of 25 plus 24 minus 6.
Well, because it's already minus, so 25 minus negative 24 is plus.
Explain it again.
Because you're doing x is negative 24, you're going to plug in minus and negative is plus positive.
Because the original equation is minus 6.
Yeah, so when you have two negatives, it becomes positive. Mm-hmm.
Because of the minus x. Is that clear, everyone? Yes?
Yes.
So when I plug in negative 24 with minus in front, must be positive. It becomes positive. Okay. So now this will become the square root of 49 minus 6, which is 7 minus 6, which is 1. Now the final question here is asking us to find f of 25 minus 2p. So let's take a look at the function. Please dictate, but this time I would like to see a parenthesis in there, and then we'll talk about it, how to continue. So,
Square root of 25 minus negative 1 parentheses 25 minus 2p.
excellent. Is this clear? Is this clear? Any questions? Please stop me if you have any questions. We've repeated the same procedure with 16, with negative 24, and now with 25 minus 2b. Awesome. So then we simplify. 25 minus 25 and plus 2p minus 6. These two go away. So the answer would be the square root of 2p and outside minus 6. Any questions for me? Any questions? Okay, in the next section, which is 2.2, I have two major concepts to work with you on, and then we look at little pieces. We're going to tie up the loose ends. But the two major topics here we're going to talk about. The first one is piecewise defined functions. Piecewise defined functions. The second topic, and I just want to mention it, I don't want to write it right now, is difference quotient. These are two major topics in this section, and a few other little things that we are going to go back to. What is a piecewise defined function? For example, it's a function that is defined by at least two functions. It can be 3, it can be 4, it can be 10, it can be infinite. So it's defined in pieces. What does that mean? Well, it means that for x values to the left of 0, I'm using this function. For x values to the right of 0, I'm using this function. Do we have an example from real life of a piecewise defined function?
Medical, when you have, go off a patient's weight and turn it out in milligrams, but it depends on that really doesn't exactly work that way. Like if you have infants, you use a significant less dosage and the ratios change the weight and the age.
I would have never come up with that. I will use it. Can I use it for other classes?
Good luck, I barely understand it.
Here it is. Awesome.
There you go.
It's a perfect example. Thank you. It's a wonderful example.
Rate to age.
So-
Rate to age.
We get a medication, right? We buy some medication from the pharmacy, and we look on the prescription, and we look up, not a prescription, on the instructions, right? And it says, if you are between ages of 0 and 5, you can only take 1 tablet a day. That's one function. That's the first piece. If your age is between 5 and 15, you can take 2 tablets a day. That's the second piece. Now I'm moving on. If you're between 15 and 60, you can take 3 tablets a day. And if you're, yes,
So
Garrett?
that means didn't mean interrupt. So that means a piecewise function could have more than 2 functions to go after.
Correct. That's why it's called piecewise. Has at least 2 pieces or more. Here's another example. That's a perfect example, a very nice example. Thank you. So the example I give to my students normally for something like this is this. I don't know numbers, I'm making up numbers, and I'm making up percentages. But it's something related to the tax code. A person who's making between 0 and 20,000 may pay 2%. That's a function, 2% of the salary or the income. A person who's making between 20,000 and 50,000 may pay 3%. That's a second function. Someone between 50,000 and whatever, 10%. 3 pieces I gave you. So it's an important type of function, piecewise defined functions. Now, the issue here is we're asked to graph it. Why are we asked to graph it? It's because we may see something like this in real life situations, and we should be able to
Read it by the graph.
correct exactly what the example was. It was a wonderful example with concentration of medication for different ages. Awesome. Thank you. That's perfect. Okay, like every time you're asking me to graph a function, I will always find the domain first. Because I don't know what to plug in. I don't know where my table starts. Because I will always use a table or a chart of ordered pairs to graph. In order to identify the domain of this function, I have to look, and again, you may have seen this kind of problem before. I always say to my students, if it works, don't change it. So if you know a different method of graphing such a function, forget about mine. Only adopt my method only if it's easier than the one you know. If it's not easier than the one you know, do not change it. Okay, so please keep that in mind. Okay, so first what I'd like to do is I change this into interval notation. Can anyone give us the interval notation for this?
X is less than
Interval notation, negative infinity to, perfect, with parentheses, correct? Can anyone give us the interval notation that replaces this? Excellent. Good. So now look at this interval and give me the domain. This will not always be true. But in this case, what is the domain?
Negative infinity to 0.
Perfect. Excellent. Indeed, this is all real numbers. We have everything to the left of 0. We have 0, and we have everything to the right of 0. Is that clear? Everyone? Yes? Edison? I have everything to the left of 0, and I have 0, and I have everything to the right of 0. Better?
Yeah.
Perfect. Awesome. So now I can start my table. What is the key x value that has to be in the table? For sure.
0.
Yes. Can anyone tell us why? Why do I have to have 0 in there? Why can't I skip 0? We will never skip 0. But why can't I? Because the function at 0, something major happens at 0. The function changes from this to this at 0.
Now,
So there must be something going on, right? Very important. Please note that there is a parenthesis facing left and there is a bracket facing right. These symbols must be touching and must be precisely under 0. I see the left parenthesis going left, right here, and the other one is the bracket going right. Bear with me, you'll understand what I'm doing in a blink. Now I would like you to tell me, for x values between these two, which function do we use? And you could say this is an overkill, because I already have it right there. True, but I want to put it on the table. So please tell me which function we use for x values between negative infinity and 0. We all agree with x plus 3. I know it's a silly question, but please bear with me. From 0 to infinity, what function do I use? Awesome. Very good. So now let's plug in some numbers. What type of functions are these? Because if they're quadratic, I need more points. If they are rational, something else. If it's, what are they? Awesome. Linear equations. So why do you think I'm going to pick negative 3?
Because it's 0.
Because it's the x-intercept. So how much is that? So it's 0. Now I would like to ask you to plug in 0 here, and you should be appalled. Because you should say, wait a minute. You can't plug in 0 in this. 0 is not here. 0 is here. So how come that you plug in 0 here? Well, if I don't plug in 0 on this side, and bear with me, I'll explain, you'll see in a minute what happens, then I will have to plug in negative 0.00000000000001. Do you want to do that? No. So let's plug in 0 and you'll see what happens. Right here inside the parenthesis, what do I write? Good. Let's plug in 0 on the other side, where I am allowed to.
6.
Good. And let's plug in also 3. Excellent. You know why I picked 3, because it's the x-intercept. Okay, let's graph this. From left to right, please give me the first ordered pair that I have to plot. Careful. Careful. Awesome. Perfect. Please give me the next ordered pair. Please give me the next ordered pair.
3.
What type of point is this?
Why intercept?
Exactly. This is an open point. Why is it an open point? Because I was not allowed to plug in 0. So this point cannot exist. And this is the first branch. No one can extend it to the right, and it's done. Next ordered pair, please.
0, 6.
Very good. 3, 4, 5, 6. What type of point is this? Yes, because I was allowed to plug in 0. The bracket says the point is full. And what is the last ordered pair I have to plot? Excellent. So here's the graph. Notice that I also graphed them in 2 different colors, just to make sure that you are not going to extend the green to the right, and you're not going to extend the pink to the left. Questions for me before we continue?